Okay, hi guys. So in this lecture, we'll be discussing on total and internal energy of a system. So let's get started. Of system. So total energy can be written as sum of kinetic energy plus potential energy and internal energy. So this can be written as kinetic energy plus potential energy plus internal energy. So kinetic energy would be there due to motion of system, due to motion in system rather, or of system. Both are correct, motion of body or system. Potential energy would be due to the presence of external electric or magnetic field. Presence of external electric or magnetic field. And U would be there because of U is simply the internal energy. Okay. Next, so we can write that at rest, if the system is at rest and there is an absence of any kind of magnetic or electric field, kinetic energy of a system would be considered as 0, and similarly potential energy would also be 0, and in this case total energy would be equals to the internal energy. So E would be equals to U, other internal energy. Okay. Next, let us see the internal energy of gas molecules or system. So total of all possible kinds of energy or energies of molecules present in a system is the internal energy. Total of all possible kinds of energies of molecules present in a system. Okay. And internal energy can be written as translation energy plus rotational energy plus vibrational energy plus energy due to attraction or repulsion within the gas molecules of the system. Energy due to attraction or repulsion. Okay, and plus more types can also be added, but those are out of the scope of our syllabus. So we can write that internal energy overall can be written as the kinetic energy and potential energy of the gas molecules. Okay, so if we say that if U is constant, this is of the gas molecules, not of the system. Okay, so if U is constant, then we can say, then if kinetic energy of the system, or rather the kinetic energy of the gas molecules increases, then their potential energy would decrease. Okay, so previously we discussed that we are ignoring kinetic energy and potential energy. So how is it different from when we are saying that kinetic energy overall is kinetic energy of the gas and kinetic energy of the plus the potential energy of the gas? So in that case where I told that kinetic energy, this is of the at system level, kinetic energy at the system level would be 0. Okay, so by system it would be considered at the center of mass of the system. So this system, this vessel will not be moving, hence velocity of center of mass of the vessel would be 0, but the gas molecules inside the vessel would definitely have some kinetic energy. Similarly, there is no application of electric field or magnetic field of any sort, hence the potential energy of the system is considered as 0. Okay, so this here we are talking about the potential energy and kinetic energy of the system, and here we are talking about the kinetic energy and potential energy of the gas molecules. So there is a difference. Kinetic energy and potential energy of the system is always considered 0, and kinetic energy of gas and potential energy of gas would have some value that would be contributing to the overall internal energy. Next, let us discuss the types of equilibrium. So first we will have thermal equilibrium, which is based on the equality of temperature, or rather not equality, we can say based on similarity of temperature. So I think both of the words remain on, I think internally mean the same, similarity or equality of temperature, whatever you want to call, similarity or equality of temperature. As in, what I mean to say is, suppose we have two systems, one at temperature T1 and another at temperature T2, and if we connect them, then both of the systems, which is system A and system B, would be at thermal equilibrium with both temperatures as T. Okay, so when this state occurs, then there will be no heat transfer through this conductor. Okay, next is mechanical equilibrium. So mechanical equilibrium is based on the equality of pressure or similarity of pressure. Equality of pressure. Okay, let's say we have two chambers, both are connected to each other, both are having some gases. Okay, this is gas A and this is gas B. So these two gases can be said or tweaked in such a way that the pressure in both the chambers remains the same, hence the condition of mechanical equilibrium is achieved. Next, we'll have material equilibrium. Okay, so in material equilibrium we can say that the number of moles of every substance in a definite phase remains constant. Number of moles of every substance indefinite phase remains constant. Okay, material equilibrium is actually dynamic in nature. So with this we come to the end of this lecture. In the next lecture we'll be seeing phase equilibria and physical equilibrium. So till then, good luck and goodbye.